This is drawing lesson 17, and before we begin, I'd like you to take a look at this painting and think about what makes this composition so unified and powerful. So this lesson is about the illusion of depth. The third dimension. The figures that are sitting at the table are resting inside a sphere. The figures hug the one side, and we, the viewer, complete the circle. The effect draws us powerfully into the painting. Caravaggio was not after a kind of photographic accuracy with this image, but a profound interaction between art, artist, and viewer. Simple geometric forms can be implied in a work of art, thus heightening our emotional response, although we might never know how the effect was achieved. Art is not created by a direct transcription of the visible world. If you want to test this concept for yourself, trace a photograph. It obviously would be accurate in a basic way, yet you would find it surprisingly unconvincing, lacking both in life and artistry. The art comes in through the artist's intention. Transforming ordinary life into art requires becoming an astute observer. Infusing flat images with volume can unify diverse elements, creating a coherent whole. The artist usually has no wish to duplicate appearances. He translates, indicates, and perhaps exaggerates. He goes to nature for inspiration, but his work bears the stamp of his own personality. He is an interpreter rather than a copyist. The use of perspective and the diminution of value create the effective illusion of a large depth of field. Identifying geometric solids. Can you find the rectangle in the body of this bottle? Can you find 6 triangles? Every transitional angle is a portion of a triangle. Being able to identify two-dimensional shapes that make up a subject is an important first step to really seeing. Once you understand this concept, the next challenge is to take those flat shapes and shift them into the third dimension. The circle becomes the sphere, the triangle a cone, the rectangle a cube or cylinder, and so forth. Hold up a bottle. Ask how many two-dimensional shapes do you see in this bottle? Squares, triangles, circles, etc. All of the objects in the natural world inhabit 3 dimensions, meaning they have height, width, and depth. Your vantage point will determine how much depth you see at any given moment. The complex objects seen all around us can be more easily understood when thought of as a composite of basic solid forms. The infinite number of complex forms found in the man-made and natural world can be represented with just a few building blocks. The knowledge of simple volumes will grant you a reliable entranceway into our 3-dimensional world. Our man-made environments are often constructed and filled with geometric shapes forged from architects' plans and designers' sketches. At the top right, I've pulled out a few geometric solids concealed in this drawing. See how many more you can find. The sphere. A sphere is a globe. It's a highly versatile shape found in more places than you can imagine. A sphere has a few main ellipses that anchor it as a volume, rather than allowing it to flip into the shape of a two-dimensional circle. Spheres are easy to spot in architecture. Look for a sphere every time you see an arched dome. If you go into an apse of a church and look up, you'll notice the space is anchored around the design of a sphere. Likewise, all arcs hint at a circle or sphere. For example, the flat shape of an eye can be graphically enhanced by imagining it as an orb sitting in a socket. The rim of the lids as a full ellipsis wrapping around the globe of the eye. An orange is obviously a sphere, yet the base of a water pitcher, teapot, or a bulging mussel may be based on the sphere as well. Common everyday objects like this jug are a treasure trove of shapes to study. The knowledge necessary to create a convincing rendering of volume comes from the ability to visualize an object's underlying shapes. The cylinder. A cylinder can be found in fire extinguishers, candles, bottles, silos, and so forth. If the object looks like a rectangle when seen straight on, it has a circular end when tipped, it's a cylinder. The sides of the shape are expressed with straight lines, yet its width is best described with arcs. Describing both attributes, the strength of the straight lines and the continuous curve of the surface, gives a lot of information to the viewer. A fundamental geometric shape, the cylinder is defined by its parallel sides and elliptical extremes. The cube. Any right-angled form can be represented by a cube or a rectilinear solid. Boxes, houses, books, and computer cases are obvious examples of these structural solids. Yet some more hidden uses of cubes can be found in organic forms, such as knees, wrists, and ankles. The torso, pelvis, and head can similarly be imagined as cube forms. The faces or facets of these cube forms help give objects a distinct orientation, allowing us to identify in what direction they are headed. The 3 planes of the brick give the viewer a sense of height, width, and depth, all of which are necessary to have the image sit firmly in space. The cone. A 2-dimensional triangle can be transformed into several different 3-dimensional constructions. The cone is perhaps the most common. Cones have a circular base that comes to a point at the center of the very top, the apex. Anytime I see an object that has straight sides that are not parallel, it suggests the cone. An ice cream cone or a teepee is obvious, yet a paper coffee cup or the neck of a wine bottle both have a slight tapering and would be represented by a cone as well. Some trees can appear conical. Look at an evergreen tree, for example, and see how the expansive bottom branches get smaller and closer together as you move up toward the top. Some gourds also reveal a creative organic use of the cone. Here, the closely packed shape never loses its geometry, yet this drawing contains all the imperfections that make it beautiful, unique, and carefully observed. The pyramid. A pyramid or tetrahedron, a 3-sided pyramid, is essentially a cone with a square or triangular base. If you have a tapered angles but see planes rather than ellipses or arcs, consider the pyramidal form as the way to go. Pyramidal forms are found mostly in architectural elements such as the rooftop of a tower like Big Ben. Any square-shaped base that tapers into a narrower neck forms a segment of a pyramid. My salt shaker has a faceted base and transitions into a round silver cap. The transition between the two is a pyramidal character. A pyramid is a highly stable structure, both physically and visually. Most of its mass rests upon the ground. The geometry found in art does not only exist in individual objects, but also in their composition. Here, Blake has organized his figures into a memorable unit, the pyramid, conveying unity and hierarchy to the viewer. This 19th century artist conceptualized the giant press as a geometric solid. Although it was subdivided into countless smaller forms, it never lost the compact impression of singular unity. Using simple geometric forms. Mastering the ability to identify the underlying structures in what you see makes drawing those things easier on 2 fronts. First, you can use these large volumes to help you conceptualize what you're looking at. And second, articulating the 3-dimensional shapes in your drawings can help you orient your forms in space. When you start thinking of internal shapes in this way, a subtle but important shift frequently happens. The fullness of your forms becomes undeniable. Matter pushes out, it has girth and fatness. By visualizing internal shapes, you inadvertently leave more room for the form. Also, you create an interesting integrity across the body of the image when you construct it from volumes. This type of thinking is, by its very nature, precludes you from contour drawing, just tracing the outline of your subject, without any thought of what's happening on the other unseen side of the object. In previous lessons, we learned to find accurate angles in your subject by noticing the changes in orientation as they relate to your knitting needle or plumb line. Larger shapes can also be determined with your needle when you realize that any time a line angle moves away from your needle, it also indicates a change of shape and a change of plane. When you see angle changes, it's a good indicator that what you're drawing will not be a single shape, but a composite of different forms. Eventually, you'll get so comfortable with this process that when you see an angle change, you'll automatically understand that this is also a plane change, even without formally citing it. Memorize the anatomy of geometric solids as they form the building blocks of complex structures. Take time to practice identifying the geometric shapes you see around you. Try to see them in everyday objects, and also try to sketch them in a notebook dedicated for this purpose. For instance, as seen here, the human hand can be visualized as a sequence of rectilinear solids. Creating drawings such as this will help you begin to become sensitive to the ubiquitous nature of volumes. Start with easier to decipher man-made objects and work your way up to the organic forms in nature. So for your assignment, I want you to draw hands because it's a very anxiety-inducing thing to do. It's something that most people like. They'll draw this beautiful form and then they'll just struggle with the hands. So having a way to formalize the soft anatomical curves into planes and volumes provides a reliable entranceway to begin your drawing. Practice drawing hands by copying the ones you see here. Pay attention to the breakdown of basic shapes and how they mold the whole picture.